In this video, we'll be finding the maximum likelihood of the geometric distribution. That is, we'll first find the expected value of x when it is 1 all over p. For more on this topic, you need to subscribe to this channel. You cannot find the expected value of x equal to 1 over p without finding the maximum likelihood estimation for the geometric distribution. Solution. If x follows p, it means that p will be equal to p multiply 1 minus p all over x minus 1. So this is the formula for the geometric distribution. So it then means that this will now be our function. The next thing to do for the maximum likelihood estimation, first we'll find the likelihood function of p, which is equal to the product sum running from 1 to n of p multiply 1 minus p raised to the power of x minus 1. So the product sum will be equal to p multiply 1 minus p raised to the power of x1 p1 minus 1 multiplied by p2 1 minus p raised to the power of x2 minus 1 multiplied by, it continues like that to give us p raised to the power of n 1 minus p raised to the power of xi minus 1. If we group these together, we'll get our likelihood function of p to be equal to p raised to the power of n into 1 minus p summation xi's, because if we sum the whole of this, it will give us summation xi's minus n. If you also sum a constant, you get n. So this is what we get. The next thing to do is to take the log, because we are looking for the maximum likelihood estimation first. So we take the log function. If we take the log of this, we get n log p plus, if we take the log of this will come over summation of xi all over n log 1 minus p. So this is what we get. For maximum likelihood estimation, the next thing to do is for we to take the derivative. So if we take the derivative of this, we'll get if we differentiate this function, we'll get n all over p. Plus, if we differentiate this, we'll get summation of xi all over n all over 1 minus p. From composite function, as we are differentiating this p, we get negative 1. So it will now be multiplied by negative 1. So the next thing to do for maximum likelihood estimation, to get the maximum, we equate the whole of this to 0. So if we equate the whole of this to 0, we get n all over p. Because of this negative sign, we get minus summation of xi minus n all over 1 minus p equal to 0. Of course, we can do the arithmetic here. From mathematics, we have that n multiplied 1 minus p multiplied by summation of xi's minus n is equal to 0. Of course, all over p 1 minus p. Of course, this will multiply 0 for we to get n into 1 minus p summation of xi all over n sorry, minus n is equal to 0. So this is what we get. If we open the brackets, we get n minus np minus p summation of xi's plus np to be equal to 0. Of course, this will cancel this. So we are left with this and this. So we move over to this other side. We move over to here. So we have that from here, what is remaining is n minus p summation of xi to be equal to 0. So we have that this can go over to this side to give us n to be equal to p summation xi. So our p estimate will be equal to n all over summation of xi. Of course, we know that the opposite of this is the mean. And we are asked to find the expected value when x is equal to 1 all over p. So we go over to this side again. For more on this topic, you need to subscribe to this channel. So the next thing to do, if the expected value of x is equal to 1 all over p, which we are asked to find, we should also note that the expectation for the sums, the expectation of the summation of xi will be equal to n multiplied by the expected value of xi. This thing means, of course, what we are supposed to write is that we are supposed to write summation multiplied by expected value of x. So if you're summing a constant, then you get n times that constant. That is why this summation sign has to turn to n multiplied by the expected value of xi. So this gives n multiplied by 1 all over p, which is equal to 1 all over p, which is equal to n all over p. Of course, if we come here, the expected value from what we got here of our p estimate is equal to the expected value of n all over summation of xi. So this is equal to n all over, we already have our summation of xi's, which we have looked for here. The expected value of summation of xi is n all over p. So we have n all over p. It then means that this n can be written first multiplied by, if this is going over to this side, it becomes p all over n. Of course, this can cancel this. Then the expected value of p estimate is equal to p. That is what we can show if the expected value of x is equal to 1 all over p. Of course, if you also come here, you can also form an arithmetic here to prove this, that this is correct, because n summation of xi all over n is equal to our mean. Then if you have n all over summation of xi is equal to 1 all over x bar. Of course, This is the same thing as the expected value of xi. If the expected value of xi is equal to 1 all over x bar, it then means that if p is equal to this, it then means you have 1 all over p. That is, if you want to use this pattern, but this is what we are to do to get the expected value, which is equal to 1 all over p. For more on this topic, you need to subscribe to this channel.